Yeah. Okay. Hello. Um, so yeah, first of all, I want to remind people that we're not meeting at the regular time on Thursday, and instead I'm gonna give a lecture by Zoom tomorrow morning. If you can't make that time, then it's gonna be recorded, so you can watch it out.
Wait, what
Um,
time is that, Tom?
10:40, is that right?
Is that here?
No, I'm gonna be in Berkeley, so it's yeah, just by Zoom. Um, uh, yeah, I used to in the old days before Zoom, I used to like arrange makeup classes. You have to reserve a room and it's a mess, but this is much simpler. All right. Um, and in case didn't see my email, like I realized that the reading for that like in theory you're supposed to do between now and 10:40 tomorrow morning is really long. Um, well, like first of all, I mean, I did it today, but yeah, if I mean, do as much of it as you can. I'll, you know, I mean, I know not everyone does all the reading anyway, but for those who like to do all the reading, um, but so I mean, I highly recommend doing all the reading. This course is about the reading. So if you don't do it, you won't know what I'm talking about. Having said that, tomorrow I'm gonna not assume that people have done it all. It's yeah. Um, all right. Uh, so let me introduce this um book. Yes, I should introduce Carnap himself, but I didn't write down his dates in these notes. So, go to Wikipedia. There we go. Rudolf Carnap, 1891 through 1907. And he was born in Germany, and his education was in Germany. Afterwards, he moved to Austria. That's where he started teaching in Vienna and then in Prague. Um, and then after that, he moved to the United States. Most of the logical positivists were, I think I said this before, most of the logical positivists were fairly left-wing politically. So they pretty much had to leave um, Germany, Austria, Europe when the Nazis came to power. And a lot of them ended up here. Um, so, was there a question or is it just okay? Um, uh, yeah, I could say a lot more about his like background and whatever, but I won't. But I guess I wrote down in my notes last time I talked about this course. So, well, I spent way too much time on the first few sentences of the notes. Trying to get through them. So this book, which, as I said before, everyone calls the Aufbau, right from its German title. So in this translation, which is the only translation, it's called the logical structure of the world. And structure is the word that's translating Aufbau. And Aufbau is like I mean, it can be translated structure. It's like something to build up. Um, so this was published in 1928 or 29. The preface is signed 1928, but I think it was actually published in 1929, or anyway, approximately. Um, so uh, I'll just say quickly that when I was in graduate school, which was a long time ago now, like 30 years ago. Um, the received wisdom about this book, about logical positivism in general, and this book in particular, was that it involved some kind of fairly simple-minded mistake, which Quine had pointed out. Um, so people weren't very interested in it, or if they were interested in it as like the history of a mistake. Um, uh, so I mean, we'll see where that comes from because we are going to read something by Quine, and see like where Quine thinks the book goes wrong and what can be said back and forth about that. But yeah, so in those days, this book was out of print in German and in English. But like one of my professors assigned a little piece of it to us, and I was like, oh, this is interesting. And I went and like read the rest of the book. And I thought, wow, this is actually like important. And a lot of other people, or at least some other people, were thinking the same thing around the same time, I think. So that in the 30 years since then, this book has come back into like people are more interested in Carnap and in this book in particular. Um, so I'm going to teach pretty much what I think Carnap means and what I think Carnap is doing. But when we get to Klein, we'll see the origin of the older way of thinking about it also. Um, and yeah, I mean, Quine also does not involve a super mistake. So, all right. So, um, other questions about the book or about Carnap before I go into the details here? Okay. So there's kind of three uh three parts to like how I want to discuss this book. Um, so like one is, which is the hardest one, but I'm gonna write it first, is something like, what's up with this book? Right, like what is Carnap really trying to do here? What's important to him? Why is he doing this? He doesn't talk about that very much, although he does talk about it some in the preface. So, obviously, in a sense, this is the important question to ask about a book, right? But especially because of what this course is about, there's another question is what does it have to do with science? And again, like if you read the preface, you know it has something to do with science. Um, or if you read almost any page of the book, you probably figured out it has something to do with science. But it's not, again, it's not clear exactly what. Um, and the final thing is technical details, of which there are a lot. um, and they're important for understanding, I mean, first of all, for understanding how Goodman and Quine are gonna, and Neurath are gonna react to Carnap. They're important for answering these other questions because whatever Carnap's trying to do or whatever has to do with science, he thinks that this technical system that he's setting up is the way to address it. They're also they're just like historically important, like a whole ways of thinking in analytic philosophy trace their origin back to things that Carnap tried to do here. So I am going to talk about those, and I'm going to kind of like mostly, well, I guess I should also say, and they're also important because if you don't understand them, then the book's going to be like gibberish, basically, right? So I mean, it's a pretty technical book. So I'm gonna talk about more about this today and probably even more tomorrow morning. And then after that, I'm, but with an eye towards what the answer to these are. And then after that, I'm going to try to get back more to that. Um, uh, so, but I mean, again, if you read the preface, you know at least that the book involves a version of the strategy that I mentioned of science philosophy reacting to science, where we say philosophy should become more like science, and then philosophy will make progress the way science does. One among many, many versions of that strategy. But it also, I think it becomes clear, especially when you get to the end of the book, that it involves also the strategy of what's left over that science doesn't do. I mean, in a sense, Carnap's answer is nothing. There's nothing left over. But in another sense, that's not the answer. So we'll see. All right. But for now, I'm going to talk about what's the technical project of the book. So it involves what Carnap calls construction theory, right? The book is about construction theory. Yeah, actually, this should be called constitution theory. The German word is Konstitution. And in my notes from the last time I taught the course, I wrote that, and then I wrote in parentheses, discuss. And this time I crossed that out and said, no. Right, so I'm not going to discuss that. We're going to call it construction theory. All right. So the basic idea of construction theory is the reduction of concepts. I mean, that is construction and reduction. These are basically the same thing in opposite directions. So what's the basic idea here? Well, suppose we have a axiomatized arithmetic of the natural numbers. Right, so we have like a set of axioms from which you can deduce and a few definitions too, like a definition of addition and stuff like that, from which you, and some of these axioms and using these definitions, you can deduce all the theorems of natural number arithmetic, right? The natural numbers are 1, 2, 3, 4, etc. Sometimes people start with 0 and other times start with 1. Anyway, those are the natural numbers. So, okay, so suppose we have that, right? The axioms are going to be stated in terms of the successor function, or the successor relation that I mentioned last time, right? Like one is going to be that there exists something such that it does not exist something such that X is the successor of Y. Right? There's some natural number that's not the successor of any natural number. Which one is it? 1. in fact, you can define one as the number that, you have to prove that, and you need the other axioms to prove it, that there can't be more than one of these. Right. So then, once you proved, this says that there is at least one, once you've proved that there can't be more than one, you can then define one as the number that isn't the successor. But, so that way you could define one, and then you could define 2, 3, and 4 using the successor relation. The number that is the successor of one, so on and so forth. Again, you have to check that there's only one, and so forth. Right, so we have this system set up for the natural numbers. And now, let's say, I want to use that system to prove that, like, 3/7 is greater than 2/5. So how can we possibly do that? Right? The axioms are only about natural numbers. And I mean, like, one of the things we may have defined here is a greater than relation for natural numbers. We call it greater than n. Right? So we can prove using our axioms that, 4 is greater than 2. But you can't plug fractions into these slots. That is, this relation is only defined on natural numbers. If you try to plug in a fraction here, you get nonsense. At least that's the way Carnap understands the situation we're dealing with here. Right? So the fractions of the natural numbers are not isogynous. So even though we have a greater than relation, it's not the same as this greater than relation. This greater than relation is defined for rational numbers. And you might say, aren't natural numbers a special case of rational numbers? But actually, in this way of looking at things, we're gonna identify one of the rational numbers with one, but they're not the same, right? Like we're gonna call this rational. I guess put it this way: we're gonna show that there's some rational numbers that have the same structure as the natural numbers, namely 1/1 and 2/1 and 3/1. But they're not the same as these. And again, they can't be because you can't plug rational numbers into these slots. Right. So there's our problem again. How I want to prove this. So like no amount of working with these axioms is ever going to get me to that. So I have to find a way to like introduce new concepts that weren't in my original system. Or a new kind of object that wasn't in our original system. And as you'll see when I say how to do it, I think you can start to see why Carnap says you can look at it as concepts or you can look at it as objects. So the way it's going to work is let's say we'll define 3/7 as, and first I'm going to use like modern set theory notation. So we can define, well, I guess I wrote it down for 2/5. So we can define 2/5 as a set of ordered pairs such that I guess maybe I should start a step back. You might think you could define 2/5 as an ordered pair of natural numbers. You know what an ordered pair is, right? I think it should be clear from the phrase what an ordered pair is. It's two things, but the order matters. right? So you could say, I mean, you can't define 2/5 as just like the set containing 2 and 5, right? Because one of them has to be the numerator and the other has to be the denominator. Order matters. But you might think you could define it this way. It's the ordered pair of 2 and 5. But the problem is that 2/5 equals 4/10, but these are two different ordered pairs. The ordered pair 2, 5, and the ordered pair 4, 10 are different ordered pairs. So they're not equal to each other. So if you define 2/5 this way, and define 4/10 this way, then you would find the two things that are equal to each other, when you plug in the definitions, are not equal to each other. And that's obviously, you got something wrong, right? So instead, you say, well, it's, and I guess like, here's another way of writing the same thing. So we can define a relation between ordered pairs of natural numbers by, we're gonna say that they twiddle each other when right, this is just turn them in your mind and cross multiply, and you'll see that that's the right definition, right? So we're gonna say that two ordered pairs twiddle each other when this holds between them. And then we can define this as all the ordered pairs that twiddle to kind of. So now, for example, 410 is going to be a member of this set. Right, and these two definitions are the same thing, as I think, as you can see by comparing all these things, right? So um, right, because if x, y twiddles 2 comma 5, then 5 times x has to be equal to 2 times y. And vice versa. Right. So and so 410 is going to be a member of this set, and 6 15 and whatever. Right. So like we're part of the way there, but we still don't know how to prove this. Right? I mean, we can't, this set again can't go in these slots. So it's not it's not the natural numbers greater than relation that's going to hold between this set and another set. We have to say what the relation is. And Carnap says this on page, I didn't write it down. It's on page 69, I think. That is, he gives this example. Page 16. Well, anyway, Carnap does give this example. And so we can transform this statement that involves these two rational numbers, 3/7 and 2/5, into a statement that only mentions natural numbers. And here's how to do it. The board. For any two natural numbers, x and y, if 7x equals 5y, then 3x is greater than 2y. This is the transformation of this statement into a statement that only involves natural numbers. Why does this work? Well, I mean, when you say that 7x equals 5y, you mean that like the same unit, so to speak, can be divided into 5 pieces. And each one of these is x. And it can also be divided into 7 pieces. And each one of these is y. Right? So x is a fifth of this unit and y is a seventh of this unit, right? And we're saying that whenever you do that, when you then take 3 of these and compare to the 2 of these, no, sorry, when you take 3 of these and compare to the 2 of these, so I haven't drawn it right because this is true. 3/7 is greater than 2/5. But on the board, it looks like it's not true. But anyway, but notice it doesn't matter at this stage whether it's true or false. I mean, in this case, it's true and we want to prove that it's true, but it could be that it's false and we want to prove that it's false. Either way, we have the same problem. We need to change our statement about rational numbers into a statement that only mentions natural numbers. Right? So again, we're saying that if you divide anything into 5 parts, and you divide the same thing into 7 parts, that's this, 7x equals 5y. I guess this is x. If you divide anything into 5 parts and you divide the same thing into 7 parts, then if you take 3 of the 5 parts, you'll have more than if you take 2 of the 7 parts. Or no, the other way around, right? Okay, but there's still one more step, and it's not hard, but I'm not going to do it in detail. But basically, you have to check that this defines a relationship between classes like this. Meaning, it doesn't matter whether you take 2 and 5 here, or take 4 and 10, or 6 and 15. Right? If you take any member of this class, it's going to make the same statements like this true. And I mean, that had better be true or else rational number multiplication won't work or whatever, right? So now you know how to, I mean, first of all, you know how to completely get rid of rational numbers by that is assuming I fill in all the others, right? Like, first of all, you have to make this into general rule. That's not very hard, right? But then you have to define addition or multiplication or whatever. And then you can show how to take all these statements that involve rational numbers and change them into ones that just involve natural numbers. But also you can see how to understand statements about rational numbers as being about these special weird kind of objects, classes of ordered pairs of natural numbers. And we've defined special relations between these classes of ordered pairs. Right? And Carnap thinks of these not as classes of ordered pairs, but as relation extensions. So in his notation, this looks something like, I mean, that is in a hybrid of his notation and my notation. He doesn't use this twiddle and whatever, right? But this is the idea. This is a propositional function. You plug in x and y in that order, and you get a particular proposition that's either true or false. So you plug in 4 and 10, you get a true proposition. You plug in 4 and 11, you get a false proposition. He thinks of this as a kind of generalization of a class or set. right? It's like a class or a set, but a class or a set is just the extension of a one-place predicate, all the things that are A. Whereas this is the extension of a two-place predicate, all the things that are related to each other in this way. When I say all the things, for each X, there's a Y, right? So these things have this like two-part structure. I think I explained that much more clearly than I ever have before, but I know some people are probably not very happy with that. Are there questions about this? By the way, so this Carnap introduces this example because this is the type of example that he found already worked out by Frege and Russell and Whitehead, right? He didn't invent this. They applied this new system of mathematical logic to building up classical mathematics. So they did all kinds of things like this, all kinds of constructions like this. We start out with base numbers that are natural, base objects that are natural numbers, and we introduce these new things that we're going to call rational numbers by constructional definition, and the constructional definition takes the form of like identifying each new object with a kind of propositional function referring to the old objects. Or as we can say, to a kind of set involving the old objects. And now I hope you can see why you could call this a concept or an object. You can think of it as the concept of numbers having this relation to each other. Right? It's like, or it's the extension of the concept, numbers having this relation to each other. You may not know the word extension. Do you know the word extension in this context? Yeah. That's important. Carnap uses it a lot, and I think he kind of assumes that you sort of already understand it. So take a regular concept, a one-place predicate. Right, so one place predicate is something where it's a propositional function where you have to supply one thing and then you get a proposition. So it could be like these are rows. Right, you understand I'm calling this a propositional, like a function from real numbers to real numbers is something where you give it one real number and it gives you back another one, a unique one. Right? Like, so, if the function is x squared, then that means that, if you give it 2, it gives you 4. If you give it 3, it gives you 9. So this is also a function, but it's not from real numbers to real numbers. It's from things to propositions. Right? So, like, I give it this piece of chalk, and it gives me the proposition, this piece of chalk is a rose. That's a false proposition, but it's a proposition, right? I give it some rose and it gives me the proposition, let's say I have a rose named Fred. I give it the rose named Fred and it gives me back the proposition Fred is a rose. That's a true proposition. So this is a propositional function. Or you can call it a concept or a property, I think is what Carnap usually calls this. So its extension is the class of all the objects that give you a true proposition. So in this case, it would be the class of all roses. That's the extension. Is that clear what extension means? Right. So, when you go to these two-place predicates, it's a little harder to imagine what the extension is, but it's still, right, it's the pairs that make this, that are in the right order that get a true proposition. So in this case, like 2, 5 is part of the extension, 4, 10 is part of the extension, 6, 15 is part of the extension, like 4, 11 is not part of the extension. So you can think of this class of ordered pairs or this like propositional function, the extension of this propositional function as like you can think of it as a new type of object that you're introducing, or you can focus on the fact that it is the extension of the new type of concept you're introducing. This is what Carnap calls the object of a concept, right? He says every concept has one object, not to be confused with the objects that fall under the concept, right? So like in this case, the objects that fall under the concept would be all the individual roses. But what Carnap is calling the object of the concept is the class of all roses. And what he's saying is introducing new objects that are classes is the same as introducing new concepts. It does, you can look at it either way. Introducing a new concept, you can look at as introducing the extension of a new concept. Is that, I mean, there is one issue about that, which is that you might think there could be many propositional functions with the same extension. So I have to do that with rows, but oh, like if you said x is an even prime number, and x is the successor of 2. I'm sorry, of 1. So, right, the only even prime number is 2. And 2 is also the successor of 1. So these have the same extension. So if you look at these as different propositional functions, then you have 2 propositional functions with the same extension. But Carnap is going to count propositions for the purposes of this book. I mean, he recognizes there's other ways of treating propositions that he also thinks are fine, but for the purposes of this book, he's going to treat propositions as the same if they have the same truth value, basically, right? So, like, these really do give you the same proposition for every object you put in. Because they always give you either true, they always either both give you a true proposition or both give you a false proposition. Okay. Again, I want to ask other questions about this. I mean, I'm not sure whether it'd be better to start with one of these, like, I mean, because as I said, this is the type of example that Carnap is like basing himself off, right? This is what Frege and Russell have already done. He's going to claim that you can do the same thing to introduce all the objects of science on the basis of something like sense data. Right? So by a procedure just like this, you can start with something like sense data and introduce new concepts or new objects. It doesn't matter how you look at them, but like rattlesnake and aesthetic value and civilization, right? Like as you go up the hierarchy, you're going to get all these things. They're all going to, but it's all going to be by a process just like this. Yes.
So I have it's always not a good sign when you go to ask a question and you think you're about to look stupid, but I guess that just indicates the question is important. I'm intrigued how this goes together with his being an empiricist and wanting to found his concepts on sense data. Because it seems to me, first of all, if the goal with reducing natural and rational numbers to, right, let me read my notes and see if they're right, to write logical propositions built up out of predicates using intuitive concepts,
Well, I mean, we're reducing rational numbers to natural numbers. is the
Yeah.
way to say it. Yeah.
It seems, first of all, it seems to me that like, if the goal is that these are like logical concepts that anybody can see, I'm not at all sure why the concept of there exists a number which is the successor function of one is any more on solid logical ground than there exists a number which is two. And second of all, it's particularly unclear to me how this would lead Carnap into empiricism, because nothing about a concept like the successor function or even a concept like natural number seems to be based in sense data, really, right? I mean, if I were trying to derive numbers from sense data, I wouldn't start with the successor function. I would start with here's one finger, here's two, which is exactly the kind of example these people don't like. So why are they empiricists?
Well, I wouldn't say they don't like that example.
I mean, I know that it's not a good example because it doesn't tell you about numbers. It only tells you about fingers. But how do you get to this from sense data?
Right. So, I mean, this is supposed to be an example of the method he's going to use to get from sense data to other things. This isn't actually a step in getting from sense data to other things. It is a step in getting from fundamental logical concepts to like and implies and whatever to real number analysis and right, like all of classical mathematics. It's a step on that way. What Carnap thinks in this period is that since you can do that starting with just the most fundamental logical concepts, that shows that all of mathematics is basically part of logic. And it wasn't like he wasn't the only one who thought that. That was, Frege and Russell also were, this is called logicism, the view that all of mathematics is basically part of logic. And moreover, Carnap thinks that logic consists of statements that are true by virtue of their meaning. They're analytic, as he would put it, in a slightly later period. So that means all of mathematics essentially has no content. Right? It all consists of tautologies. I mean, like strictly speaking, a tautology is something like a rose is a rose. Right? But in an expanded sense of tautology, like statements that are true just because of the meaning of the words, can be thought of as like just saying the same thing over again. And that's what Carnap thinks that this shows about mathematics. That's another thing that Quine attacked and whatever. But like we won't really be talking about that again in this course. Except, I mean, but I mean, it's worth mentioning because so Carnap doesn't think that mathematics is empirical, but he thinks it's not empirical because he thinks it doesn't say anything, basically. It's just rules for like transforming sentences into other sentences that mean the same thing. Okay, I mean, you don't have to accept that about mathematics, but I mean, you have to understand that for that reason, Carnap and logical positivists in general, and even other people like Popper in this period also agrees with this, that think that the epistemological problems about mathematics have all been solved because it's been just shown that mathematics is just it just all consists of statements like all unmarried men are bachelors and something like that.
I think you said mathematical laws are grounded in like statements of logic. What is that grounded in then? Because it feels like
Again, it's supposed to be
if it's not like anything empirical, like psychological, where do we get logical laws?
right. It's supposed to be like it's We know them because we know the conventions of our language. Because again, it's like things that are true just by virtue of the meaning of the terms they contain. There are a lot of issues here. I mean, you're right to go. This is very complicated, but it's not what this lecture is going to be about because this book is not about this, right? But this book takes for granted that a certain like project like this has worked out in the case of mathematics. He wants to do something similar in the case of empirical science. But of course, he's not going to claim that the statements of empirical science are true by virtue of the meaning of the terms, right? He's going to claim that they're true by virtue of our sense experience. So what's going to be the same is this methodological structure, how we introduce new objects using relation extensions and classes. And also the distinction. So when I described this, you notice I started out by saying, well, we have an axiomatized system of arithmetic. So, right, that means we have a bunch of statements that we're allowed to assume are true. And then we have rules for deducing new statements from that. Those are the axioms, right? So we start with axioms, and we have rules for deriving new statements, theorems from the axioms. And that's a whole system in itself, and you could like derive all kinds of truths of natural number arithmetic using that system. But at first it seems you can't use that system to derive any truths about rational number, because it's not about rational numbers, it's about natural numbers. So we have what Carnap calls the deduction system. Right, the deduction system starts with axioms and derives true propositions from the axioms. But if all you have is this, then you're limited to, you can only use this system to proving things about the objects that are mentioned in the axioms. You're obviously never going to get any propositions that are about anything else. At least assuming the axioms are consistent, if you want. If they're inconsistent, you can derive anything. Right. So to finish this off, to allow it to deal with everything that you want to deal with, you have to add to the deduction system or deductive system. Deductional? I forget what he calls it. I think he calls it deductional system. You have to add the constructional system. And the constructional system is going to start with the basic concepts that are used in the axioms. And it's going to use constructive definitions like the one we just had here to build up new meaningful concepts. And then when you want to prove something in terms of these new concepts, you use the constructional system backwards to get back to the basic concepts. And then you use the axioms of the deductional system to prove whatever the translation, right? So as you have something here, like 3/7 is greater than 2/5. Running the constructional system backward, you translate it into something that only mentions the basic concepts. In this example, it only mentions natural numbers. And then you can use your deductional system to prove whatever it is you want it to prove, right? Because you can prove its translation. Was that clear? Maybe not. Again, right? You use your constructional system to introduce new concepts. This is the distinction between propositions and concepts that I was trying to emphasize last time. You use your deductive system to introduce new propositions, and you hope that if the axioms are true, and you assume they are, then this system will show that the new propositions you derive are also true. Use the constructional system to introduce new concepts. So there's no question of truth or falsehood on this side, right? Because concepts by themselves, like rows, are not true or false. But there's a question of meaningfulness, right? If we introduce new concepts correctly, such that all statements that use the new concepts can be translated back into the statements that only use the basic concepts. And that's what this procedure is supposed to ensure, right? Then we know that if the basic concepts are meaningful, then the new concepts are also meaningful, right? Because everything you can say with the new concepts can be translated back into something using the basic concepts. And we know the basic concepts mean something. So that thing that you translated back means something. Right, so meaningfulness is transmitted in the constructional system, whereas truth is supposed to be transmitted in the inductive system. And it's like, I mean, and I hope it's clear, these are not alternatives, right? Carnap says when you axiomatize a theory, you need both of these parts. You need both axioms and a way of deriving new propositions from the axioms, and basic concepts and a way of introducing new concepts. And again, the way you use it is you want to prove something in terms of the new concepts. You use this to translate it back into something that only uses the basic concepts. And then you go over here and you can use the axioms to prove your translated statement, right? So in this case, we're going to use the axioms of natural number arithmetic to prove this. That was the translation of 3/7 is greater than 2/5 that we got by like reversing our constructional definition. We got that translation, and then we can use the axioms of arithmetic to prove that this is true. So similarly, so first of all, Carnap isn't saying this is better than this, or we should do this instead of this, or this is more fundamental than this. No, he says we need both of them, right? The two pieces of axiomatizing a theory. But he does say that people have paid a lot of attention to this and not much attention to this. And this book is going to be about this. So in the case of empirical science, what would this look like? Well, what would the axioms be? The axioms are basically going to be some kind of statements about experiments, empirical statements, right? I mean, those are the ones we start off by assuming are true in empirical science. And we're going to try to prove other things from that. And if we have a way of introducing all the concepts that are used by empirical science over here, then we can prove all the true statements of empirical science from true statements about sense data. In principle. In principle, we can do that. Yeah.
I mean, I don't have much experience in like mathematical logic.
Yeah.
Just like symbolic logic, but I guess the only way I tend to make sense of this is like it's in like mathematics, like the language of empirical science, and so I guess that's why you have mathematical logic to prove, like, I guess the findings, in empirical science.
I mean, so first of all, I'm using mathematical logic to mean the same thing as symbolic logic. We're talking about mathematical concepts. But this logic is just the regular symbolic logic, right? I mean, although I understand that at least Terry was telling me this time that Phil 9 now doesn't go beyond one place predicates. If that's true, then it's unfortunate because, I understand why. It's obviously much easier if you only have one place predicates. But it was the introduction of two place predicates that allowed Frege and Russell to do interesting stuff like this. Um, but other than that, this should be just the same logic that you got in Phil 9. Now, is this logic useful here because mathematics is the language of empirical science? I mean, so remember, Carnap is defining science very broadly. He's defining it very broadly because he's basically in the end is going to want science to mean meaningful discourse about the world. Right? So as he goes through here, like actually I don't know if he gave any examples like this already in this intro, but you'll see plenty in the reading for tomorrow anyway, that he includes like graphology, physiognomy.
Yeah, he does, and I was like, oh my,
Yeah.
of course
Well,
this asshole's into that crap.
well, so the logical traits, first of all, he's really not an asshole. But although he may have been in certain ways, but for the most part, he wasn't.
I mean, politically, I just think he could be unpleasant to talk to.
So what he was like to talk to, so obviously, he died in 1970. I was born in 1966, so I didn't talk to him myself, but Hillary Putnam, who was my teacher, talked to him, and he described him, he said, spoke very slowly, very deep voice with a German accent, which I can't really do. And he said, you would, and it's easy to imagine Hillary Putnam. Unfortunately, we're only going to read one paper by Putnam in this iteration of this course because we have one less day because of Veterans Day normally. But we will read one later on. But anyway, so it's easy to imagine this happening if you knew Putnam. So he said he would go in there and say, like, oh, Professor Carnap, I think this, blah, 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 blah. And Carnap would say, oh, so you think. And then he would say something that obviously followed from what you just said and was obviously absurd. That was Putnam's experience of talking. Yeah. So, I mean, you can't necessarily tell from the way philosophers write what it was like to talk. Like Kant, for example, was a very popular like dinner party host. He was known for his wit. And also he was an extremely popular lecturer at a time when time and place where the students directly paid the lecturer at the end of the course. So like once he became a full professor, he had to give one free course every year or something. But other than that, he was like, he would have to rent a room and put up signs advertising, Professor Kant will give such and such a course, and people would come. And then at the end of the course, they would pay him directly. And he was very popular. So you wouldn't necessarily get that impression from reading his books. So yeah, sorry, that was kind of a digression. But what is true is, as opposed to Popper, the logical positivists were very open, we might say even naive, in what they were willing to accept as possibly part of science. Not just Freud and Marx, who, as we'll see, Popper excludes, but graphology and some of them were interested in paranormal, phenomena, right? Because, why not? It's a meaningful hypothesis. It can be tested. Yeah. So and this gets me back to what I was about to say, what I was in the middle of saying before I was thrown off course, which is, I shouldn't I don't mean to complain. You definitely should ask questions and throw me off course. But I do have to somehow find a way back. Yeah, I was starting to say, so in principle, the result of the system, if it could be completely worked out, which it's not even close, not even close to close. Right? But if the whole system could really be worked out, then in principle, you could use a chain of constructive definitions to go from any statement of like art criticism or whatever, translate it back into some very complicated statement about fundamental experiences. Determine whether that statement is true or false by examining all the experiences you actually had. And then you could say, so we know that statement of art criticism is true, right? But in real life, we don't remember all the experience. I don't remember all the experiences I had. Plus, a lot of them I haven't had yet. So when we'll see when Carnap introduces a way of thinking about this as if we were actually using it to check the results of science, he's going to say, you can introduce the fiction that all my experience is already in. And I'm not going to ever have it anymore. And that I remember every single one of them. And I have a name for each one. So I can keep track of them. Right? And then if you had that, and then you would have this incredibly complicated formula. Like I'm stretching my outside like this, but it would be much more complicated than that. Right? So you could somehow check all the experiences that you're ever going to have and plug them into this very complicated thing. And so the point is, it's not meant to actually do that. It's meant to show something about the relationship between the statements of empirical science and our experience. That in principle, it would be possible to translate one into the other. Okay, so are there more questions about that before I go on? Yeah.
I guess what were Carnap's metaphysical views? I guess because like the reason I asked is like I feel like if the way I understood what he was doing is not how he understands it, then like is he like a Platonist or a formalist? You know, because I think that to me that seems kind of like relevant. I don't understand how this is like relevant if you don't connect it to like the numbers that we have actually use in empirical sciences.
So it's not actually gonna be about numerals, really. But Carnap isn't quite as clear about that at this stage as he is a little bit later. This is what we're doing here is something that's related to language in some way. But the short answer to your question is that, so I said that Carnap, unlike the people we're going to see in the second half of the course, Carnap and Goodman and Quine are all happy to include all kinds of stuff under science. So science is like a huge, what Popper's going to call the demarcation problem, saying what is science and what isn't. For logical positivists barely exists because anything meaningful is science. So what isn't science? Well, metaphysics. Metaphysics is not science. And Carnap is basically going to define metaphysics as statements that look like they say something that could be true or false about the world, but they're actually nonsense. And I mean, when I say they're nonsense, they may serve some purpose, like to express my attitude towards something. but remember what Carnap said about Heidegger that I mentioned, that he says that basically that Heidegger is bad poetry, right? Carnap says, if you want a form of language to express your attitude without asserting things that are true or false, so that if someone else asserts what looks like the opposite, you don't really disagree. He says, use lyric poetry, don't use metaphysics. Right? Like if two poets write what looks like the opposite in two poems, they're not disagreeing with each other, at least not the way Carnap understands poetry. They're just expressing a different attitude. Right. So he says metaphysics can be used that way, but it's not actually a very good instrument to use that way. And moreover, it's confusing because it looks like science. And like, what does this definition of metaphysics have to do with what we usually call metaphysics? Well, because Carnap is going to say that all kinds of questions, like, are there really rational numbers or not? Are metaphysics. So those are both questions we normally would call metaphysical questions. And Carnap is saying they're pseudo questions. They don't have right or wrong answers. People may answer them different ways, but and they may think they're disagreeing with each other, but there's no way to settle the disagreement. And so that is nothing about their sense data can determine the answer either one way or the other. And so, so what they're really doing is just expressing different attitudes. And then like arguing with each other as if they were doing science. Right. So he's gonna mention all the way through certain disputes, like realism versus idealism, or Platonism versus formalism would be another one, right? Where he would say that the two sides agree on everything that's empirically meaningful. What they disagree about, what they seem to disagree about, is meaningless metaphysics. Yeah.
Yeah, it was just, that's what he says on page 10, right? Section 5. Thus, in construction theory, we sometimes speak of constructed objects, sometimes of constructed concepts, without differentiating. These two parallel languages which deal with concepts and with objects and still say the same thing are actually the languages of realism and idealism.
Yeah,
so
that's
I think
an example.
From his perspective, whether you experience an object because you experience the concept or whether you invent the concept because you experience the object is a stupid question that doesn't matter. I don't like this. Don't like this.
Well, first of all, it's not a stupid question that doesn't matter. I mean, that's kind of the way this got translated to Oxford, right? Like A.J. Ayer, who was one of the main British followers of Carnap and logical positivism in general. It kind of translated it to it's the culture of Oxford, like a kind of like put down culture, right? Where you're like, show that the other person is stupid. I mean, Carnap's examples are of like what metaphysics should be doing are like Ayer's examples are kind of like yay, boo, right? Carnap's examples are like poems or symphonies or something like that, right? Says he doesn't think something stupid is happening here, but he does think it's a mistake, and he thinks it's a dangerous mistake. I'll try to explain later why he thinks it's dangerous. But the other thing to say about that is, like, the question you just asked could be interpreted as a psychological question. And if it's interpreted as a psychological question, then Carnap is going to find a place for it in his system. It's how can you tell that it's not being interpreted as a psychological question? This is kind of a spoiler for something I'm going to try to argue for later, but it's basically like when you ask the metaphysician, what sense data could decide this question? They don't say, well, we're working on that, we don't know yet. They say, no, you misunderstood my whole point. Sense data couldn't solve this question. Right? Like, if, if physical objects really exist, or if they're mere creations of my mind, my sense data are the same. So you've misunderstood the question, right? So if they say that, then we know that they don't want a place in the system, right? They're refusing to have a place in the system. If they don't, then Carnap is going to say, "Oh, that's psychology," right? So, like, and that can be answered. You can study your psychological states by studying your physical states, and we can determine whether do you start off with concepts first, or do you derive them from interactions with objects, or right? Those are all good scientific questions according to Carnap. And again, his willingness to allow that something is a good scientific question is very broad. It's just enough that that you don't say, no, you misunderstand. Sense experience could never settle this question. So if you're like a graphologist, and you say, yeah, I really can't explain what it is, how you can tell that this is the E that would be drawn by an axe murderer. You have to just like, so Carnap will say, yeah, so they're saying they have sensible indicators that tell them one way or the other, but it's too complicated and they can't explain it yet. I mean, the graphologist might not add the yet, but Carnap is going to add the yet. Of course, we're working on it. Eventually we'll have a, right? And similarly, the art critic is going to say, I can't tell you how to tell if this is a really good sculpture. You just have to look at it. You kind of to say, aha, you have to look at it. That means it's based on sense. Right? I mean, otherwise, why would you have to look at it? So, like, yeah, I can't tell you what I do with what I see when I look at it. But that's just because it's really complicated. We're working on it. All right. Let's see. So I didn't get derailed quite as early as I did last time I gave this course, but I may not get any farther again. But let's see. So that's the basic project of the book. And why does Carnap want to do that project? So I mean, now, again, there's possibly kind of a deep answer to that question, which fits more under my number one that I gave before, like what's up with this book? But there's also, I think, like more detailed, somewhat technical answers to like what problems are we trying to solve by this procedure? There's what problems are we trying to solve by applying this procedure, which Frege and Russell used for the construction of mathematics? What problems are we trying to solve by transferring it to the realm of empirical science? And as he said, it's not like Frege and Russell would be against doing that. In fact, Russell especially sometimes hints that, or says some vague things about doing that, but he doesn't really try to carry it out in detail the way Carnap does. So I think there's 4 issues that Carnap thinks that seem like 4 completely different things, but Carnap thinks from the point of view of this methodology, you can see that they're really the same problem. So the first one is this as a technical problem about we would probably say, and we, because of Quine, really would say this, we would probably say it's a problem about set theory. Whereas Carnap thinks of it more as a problem about logic. Or Carnap thinks that set theory is part of logic or something. Anyway, the problem is that like a naive, simple version of set theory leads to paradoxes. I think later on in the course, I'll try to explain in detail what what kind of paradox you get here. But um, but this is something that was known already, in the later 19th century, and people were scratching their heads trying to figure out what to do about it. And this is at least part of what led to what's known as the foundation crisis in mathematics, which Carnap refers to at the beginning of the preface. And as I said, Heidegger actually also refers to it in the introduction to Being and Time. Right, so the question is like, what was the mistake we made in setting up set theory that led to contradictions? Like we start with some like really apparently innocuous principles about like having a bunch of things collected together. And in just a few steps, you get a contradiction. So that was one issue. The second issue seems like completely removed from this, which is the theory of spheres of being. Right? I think you've already seen Carnap talking about this. So this is like an ancient Aristotelian / more like Neoplatonic ontological concept. That there are different spheres of being, like there's the sphere of nature, and there's the sphere of soul, and there's a sphere of intellect, and above them all, there's the one beyond being. And the members of different spheres exist in a different sense, right? Like this is the Neoplatonic part of it, that like things down here in the sphere of nature don't exist as much as things in the higher spheres do. Right? It's a lower mode of being. So, I mean, Carnap isn't so interested in that upper lower thing, but he is interested in the idea that there are different modes of being. And the things that belong to different modes of being or in different spheres of being are more different from each other than just being different kinds of thing. Right? They don't just differ in species. There's no common genus that contains them both. That's that's kind of the way Aristotle introduces an idea like this. Carnap got this probably mostly not from Plato or Plotinus or whatever, but from Husserl. And Husserl got it from Brentano, and Brentano did know all that stuff. Neoplatonism and whatever. Medieval philosophy. So, like in Husserl's phenomenology, there's a doctrine just like this about spheres of being. There's the sphere of pure consciousness, and then outside that, there's like a sphere of sensible things and a sphere of, physical things, and a psychological sphere, and then geistlich or cultural is how they translate geistlich, a cultural sphere, right? So Carnap is basically taking those, like, more or less Husserl's spheres of being and trying to understand what does that mean. Husserl says, and again, this goes back to Aristotle, there's, here's how you can individuate sciences. There's one fundamental science for each sphere of being. Okay, so that's another issue. Number 3 is, I don't know how to put this in a brief way I can write on the board, but it's like, how can I tell if if a sentence is meaningful before I know whether it's true or false? Yeah, like, I mean, you should be able to tell apparently whether it's meaningful before you ask whether it's true or false. Because if it's not meaningful, then what are you trying to figure out whether it's true or false? Right? So you should know in advance, so to speak, whether the science sentence is meaningful. And this means that you need you need a way of, at least the way Carnap looks at it, you need a way of sorting out concepts because truth and falsehood are properties of propositions, but meaningful and meaningless are properties of the concepts that are used in the proposition. Right? So, like, if I say all roses are black, then the meaninglessness gets in because there's a meaningless concept in it. Whereas if all the concepts are meaningful and they're put together the right way, you always have to add that. That's kind of the logical part. If all the concepts are meaningful and they're put together the right way, then the proposition, now you can start asking whether the proposition is true or false. Okay. And then so far, none of these obviously, well, I did say that how this has something to do with science in a way. But none of these three obviously have anything to do with science, except maybe this one. But the fourth one is establish our right to talk about things. And where our means basically science. How is it that scientists have the right to talk about things like rocks, planets, pine trees, whatever, when all they have access to is their own experience?
What is the last one on the board say?
This
Yes.
says things.
No, like the last sentence.
Oh, the whole sentence. Establish our right to talk about things. Yeah, I'm sorry. I'm kind of incapable of writing in a legible way. But so feel free to always ask me what I just wrote. Right, that is to establish a right to talk about things that we don't have direct acquaintance with, I guess, is how you should fill this in. Right? How can science establish its right to talk about things that we don't have direct acquaintance with? This is like an epistemological problem, right? I mean, it's similar to problems that Hume worries about and so forth.
Yeah, there's
So, like, what are the limits of this? Okay, so like in Husserl, these two things are closely tied together. The reason, the justification for science talking about other spheres outside the sphere of pure consciousness is that the members of those spheres are constituted within pure consciousness. This is why, like, it might be important that Carnap really calls it the constitutional system and not the constructional system. I said I wouldn't discuss that, so I won't discuss it. Okay, so like, and it goes step by step in the sense that, like, what are first constituted are sensible, like, Husserl calls them the objects of Cartesian imaginatio. Hey, meaning like things like lumps of wax that have a color and an odor and a taste and so forth, right? They're bodies that take up space, take up sensible space and have sensible properties. I start with that. And then on the basis of that, I constitute members of higher spheres that are farther away from their, in a sense, they're lower spheres. They're farther away from the absolute realm of pure consciousness. So that is the relationship between the different spheres is the relationship of like epistemic founding, so to speak, but understood as a metaphysical process. That's Husserl. On the other hand, I think it's fair to say that Wittgenstein in the Tractatus kind of identifies these questions with each other, right? Like you can tell what things we have the right to talk about by as it says in like the introduction to the Tractatus. How does it put it exactly? We can't draw a boundary. I think it's between the knowable and the unknowable, or something like that. I forget exactly what one side is. Because on the other side is something that we can't talk about, right? So he says, rather, the boundary must be drawn within language between sense and nonsense, right? So the epistemic, what we're trying to get at when we ask about our epistemic limits is according to this really the limits of our meaningful language. That was the only thing that is recorded that we know that Wittgenstein said about Heidegger, I think. He said something about, I understand what he's trying to do. The mind runs up against the limits of language. I don't know if that's the right reading of, I mean, it is, I guess. Sorry, this course is not about Heidegger. All right. So, so to tie these together, so to speak, what Carnap needs to add is that the solution to this problem, the solution that Russell came up with to this problem, involved separating the objects you talk about into types. Right? This was called the theory of types, Russell's theory of types, and making sure that you never apply to one type a predicate that's supposed to apply to a different type. And moreover, it's a hierarchy, and it works kind of like the example we saw in when we introduced rational numbers. The members of like the classes or relation extensions of a lower type belong to a higher type. So maybe I should discuss the Russell paradox in this lecture, but obviously not this time. No time left. But I mean, the paradox here comes. It comes when we try to talk about like whether sets are members of themselves. That's how you get the paradox. And the theory of types ensures that this will never be either true or false, right? Because the sets that something is a member of are always at the next level off in the hierarchy. So you never can put X itself into the slot of something it could be a member of. That will always be a type error. Yeah.
Yeah, so in grounding everything out at like a sort of like simples level of experiences and building off of that, it kind of like imitates that type theory.
It's not just imitating, it's an application of it, right? That is, it actually is like a full-blown application of Russell's theory of types. Only the types now are not types of mathematical objects, but types of empirical objects. Wait, we still have 5 minutes. Yes. Okay. Right. So, and Carnap thinks, and he says explicitly in this book, at this time, he thinks that Russell's way of solving the problem is the only way, the only known way of avoiding the paradoxes. Now, like later, it turned out that there's other ways. And then you can start to discuss whether Russell's is a better way or a worse way or whatever. But at this stage, Carnap says, and this is what he's alluding to at the beginning of the preface, he's saying, you know, the old logic ran into contradictions. The only way out of the contradictions is the theory of types. And so we learn that in order to make sense at all, you have to use a theory of types. And so there are going to be different spheres of being, and like, at least at the finest level, the spheres of being are going to be the types, right? He also talks about these large spheres, like the ones that Husserl actually talks about, like psychological or physical or whatever, right? But within each one of those are tiny layers where everything is isogenous with everything else, where the same predicates apply to everything on that level and to nothing else. And so that's kind of the finest structure of the spheres of being is a result of the theory of types. So there have to be different spheres of being. And that explains why science is organized in this way. Yeah.
I learned about this in my discrete math class, but did he ever touch on the Gödel's incompleteness theorem?
So
That, yeah, I mean, that might be.
Gödel's incompleteness theorem.
Basically says that.
Yeah, no, I know what it is. I'm trying to remember what year it was proved. I think he already knew about
It
it.
was after, no, it was after his
It was after.
publication. Yeah, I looked it up.
Oh, okay. So, I mean, but what he's doing here is not really affected by the incompleteness theorem, I don't think. He's not trying to, it's not Hilbert's project, which was shown to be impossible, but and Carnap himself worked on, you know, new like statements of an incompleteness theorem later. So yeah, I mean, he definitely knew about it quickly, even if he didn't know about it in his book. Right, so we can understand why there have to be spheres of being. And we can understand why fitting into a structure like this is related to a sentence being meaningful. Because for a sentence to be meaningful, it has to belong to a properly set up system that doesn't lead to paradoxes. Now, I mean, that's actually not obvious, right? I mean, you might think that an inconsistent system is still meaningful. It just says everything. But I don't think that's the way Carnap is thinking of it at this stage. Yeah.
I guess I'm kind of confused about how he's even using the word meaningful. Like, I think maybe I've read too much Continental philosophy, but I really don't like when he uses the word meaning, what is it that he's saying about the set? I think he gave the example of like some made up word like leg, I think it was, right?
Yeah.
But I feel like okay, maybe it's just like a very liberal understanding of what the word meaning or meaningful is, but couldn't that word be meaningful in its like its meaning could be that it is not intelligible, and that is a thing to the person using. It's just a bit like.
So yeah, I mean, so I only have 1 minute left, so I can't do justice. No, but it's not a bad question. You haven't read too much. You can't read too much continental philosophy. Read as much as you want. But I add that you can't read too much of this either. But so but the short answer is, yeah, Carnap does recognize that there's other uses of the word meaningful, right? That is sometimes he calls this cognitive meaning or something like that, right? The point is, but what's important about it is that it's a meaningful proposition says something that's either true or false, and that we can disagree about. And if we disagree about it, there's a procedure for us to determine who's right, in principle. Of course, usually we can't really find out who's right, but in principle, there's a way to find out who's right. And so we're not involved in an endless fight about nothing, right? So on the other hand, if you say, isn't a lyric poem meaningful, Carnap, he's going to say, yeah, of course, it's very meaningful in another sense of meaningful. All right, that's all I have time to say, and I will see you tomorrow morning.